All right, today we're firing up the old virtual machine to talk about, seriously, one of the most influential programming languages ever, Java. And here's the thing, whether you realize it or not, you're interacting with it literally every single day. So let's go ahead and pull back the curtain on the invisible engine that powers so much of our digital world.
First things first, let's talk about scale. Because when we talk about Java, we're not just talking about some programming language. We're talking about a foundational pillar of our entire digital lives. Its influence is, and I'm not exaggerating, absolutely staggering.
So I've got a question for you, though the slide might be giving you a little hint. What's the invisible thread that connects the apps on your phone, your favorite streaming service, and a worldwide community of millions of software engineers? Yep, you guessed it, it's Java.
7 billion. Just let that number sink in for a second. That's the figure Oracle, the company that maintains Java, puts out there. It's a truly mind-boggling number. But what does a number that huge even mean in the real world?
Well, it means pretty much everything. We're talking about the Android phone in your pocket, the complex back-end systems for giants like Amazon and Netflix, even the software running ATMs and the navigation systems in our cars. Java's reach is, well, it's pretty much unparalleled in the tech world. So, how in the world did one single language achieve this kind of global dominance? It definitely wasn't an accident. The answer lies in one revolutionary idea that completely changed the game for software developers everywhere.
You know, our story kicks off way back in 1991 with this group at Sun Microsystems called the Green Team, led by a guy named James Gosling. They originally set out to build a language for digital devices, things like set-top boxes. But then the internet just exploded in the mid-90s, and they made this brilliant pivot, realizing their creation was actually perfect for web programming.
And this was their secret weapon, the Java Virtual Machine, or JVM. The best way to think about it, it's like a universal translator. You, the developer, write your code just one time. Then the JVM steps in and translates it on the fly so it can be understood by any device. Doesn't matter if it's running Windows, macOS, or Linux. This was a huge, huge deal. It saved developers a ridiculous amount of time and effort. And this powerful idea gave birth to Java's famous mantra, write once, run anywhere. This concept, platform independence, is really the key takeaway here. It freed developers from the absolute nightmare of having to rewrite their code for every single different operating system out there. Okay, so now we kind of get the why behind Java's success. But what if you wanted to learn it yourself? What does that journey even look like? Let's break down the first few steps for any aspiring Java developer. Every single developer's journey starts right here, with the basics. First, you've got to get comfortable with the core syntax. Think of it like the grammar and vocabulary of the language. Next up, you learn control flow, which is just how you tell your program to make decisions and repeat actions. And finally, you start to get a handle on fundamental data structures like arrays and strings, which are absolutely essential for organizing information. Once you get those basics down, that's when you unlock Java's real superpower, its organizational structure. It's a paradigm called object-oriented programming. Now, object-oriented programming, or OOP, sounds super complex, but the idea behind it is actually pretty simple. Instead of writing one long, messy script, you organize your code into these modular, reusable objects. Honestly, it's just like building with Legos. Each brick has a specific job, and you can combine them to create something way more complex and sturdy. OOP is really built on 4 main ideas. First, you've got abstraction. That just means hiding all the messy details and only showing what's needed, kind of like a simple button on a complex machine. Then there's encapsulation, which neatly bundles data and the functions that use it together, like a pill keeping its ingredients safe. After that comes inheritance. This is cool. It lets a new sports car inherit the basic blueprint of a regular car, so you reuse code and save a ton of time. And finally, polymorphism lets one thing, say a shape, take on many forms. Altogether, these principles are what make the code so clean, scalable, and way, way easier to manage. So let's say you've learned the basics and you've mastered the principles of OOP. What happens next? Where does that leave you? Let's take a look at the incredible ecosystem and career opportunities that really open up once you've got these skills under your belt. See, learning Java isn't just about learning the language itself. You're actually tapping into this massive, mature ecosystem. Think of it like a giant thriving tree. There are countless open source libraries and powerful tools, those are the branches and leaves, that make development so much faster and easier.
And it's all supported by this huge global community at its roots. And a huge part of that ecosystem is its frameworks. You can think of these as powerful toolkits designed for very specific jobs. For example, a tool like Spring is the absolute gold standard for building large-scale business applications. Hibernate makes talking to databases a breeze, and Maven just automates the whole process of building your project. These are the tools that really power professional development.
And of course, with all this high demand, it means Java skills are incredibly valuable. Now, salaries are always going to vary by location and experience, but the earning potential for a Java developer is really impressive. It's a pretty clear sign of just how crucial this language is to the entire tech industry. So let's bring it all home. What's the bottom line? Java is still, without a doubt, a top-tier skill. Its write-once, run-anywhere philosophy makes it unbelievably versatile. It's backed by a massive community, and it's in super high demand for everything from web and mobile to cloud computing at the world's biggest companies.
For over 25 years, Java has been this quiet giant, just humming along in the background of our digital lives. It's proven itself to be robust, adaptable, and just endlessly useful. So I guess the only real question left is, what are you going to build with it?